you see me?
It's a little bit wet.
Perfect.
All right, here we go. Now we're ready to talk. So, we're talking about Isaac Newton, Newton's laws. Just going through this again so that it's on camera.
Yep.
Hey. Newton's laws. 3 laws we need to talk about. It's in the Principia. Just understand that it does not say principle on the test or the midterm. All right, first law for Isaac Newton is the law of inertia. An object will keep going with the same velocity and direction forever unless an outside force acts on it. Now you might think that that's kind of a easy concept, but to be honest, back in Newton's day, it wasn't. Okay, scientists before, there was Galileo, but before Galileo, before Newton, the premier scientist of the day was Aristotle. Aristotle wasn't a scientist, he was a philosopher. So Aristotle would say, if you threw a rock here on Earth, it would hit the ground and stop. And the reason it stopped was because Joey wouldn't stop talking. The other reason is because Aristotle would say that it would stop because it's supposed to. Objects here on Earth aren't supposed to keep moving. It's kind of a dumb reason. Alright? But that's kind of a big step that we have to go from. Newton says, if you take a rock and you go out to the far reaches of space and you throw that rock, it will keep going forever. With the same speed, it will never slow down. It will keep going with the same velocity in the same direction forever. And the reason that here on Earth, when you throw a rock, the reason it stops is because gravity will pull it down. That's an outside force. And then once it hits the ground, it's going to roll, say, rolling through the grass. That grass is going to apply friction. So an object stops here on Earth because an outside force acts on it. If you got rid of all those outside forces, an object will keep going at the same speed forever. Okay? Okay. All right. You might have seen, you don't have to copy this down, but you might also think of inertia as objects in motion stay in motion, objects at rest stay at rest. So inertia is not just that an object is moving and it's going to keep moving, but it's also that if an object is sitting still, it's going to stay still and it can't move unless some other force causes it to move. Okay? Okay. So that was Newton's first law. Newton's second law is easy. I'll let you copy that down and then we'll talk.
And we'll pause here for station identification.
Newton's second law is easy. F equals ma. What does the F stand for?
Force.
Force. M?
Mass.
A?
Acceleration.
Acceleration. It'll be that simple. You're going to have a worksheet today just with that. F equals ma. Okay? The more the force, the more something's going to accelerate. Now, students have a big problem sometimes with understanding that when you apply a force, that doesn't mean you make something go. Force isn't tied to velocity, it's tied to acceleration. So if something's moving along, it has a force to it, it's going to accelerate. The net force will cause something to accelerate. There are all kinds of forces. So there will be a force that fights against. Okay, when you drive the car and you step on the gas, you can't just let it go forever. Okay, you can't just step on the gas and let it go and it's going to stay at that velocity. Right? Because there's friction. That is the case. It should be that way. However, there's so much friction within your car. If you hit the gas, got to 55 miles an hour and let go of the gas, the friction causes it to slow down.
Yes.
Right. If there was no friction inside your car, if there was no friction somewhere dragging, slowing down that car, then you could speed up to 55, let off the gas, and it would keep going that velocity forever.
Like down a hill.
Like down a hill, but going down a hill is giving an extra force to it, making it speed up. Okay. Next one up is equal and opposite forces. So, the third law is action-reaction. For every force, there's an equal and opposite reactive force. Third law, yeah. But the third law, all it really says is this, and people get confused with this a lot. If I apply a force to this ball, and when I throw it, the ball has to apply a force back. Always. Anytime you apply a force, there has to be an equal and opposite force. Anytime. If I push down on this table, the table is going to push back up on my hand with the same force. Always. If it didn't, it would be like a ghost table and I'd fall through it. That would be pretty cool. But it won't happen. Okay? Anytime you apply a force to something, I push these scissors across. When I push the scissors, it's pushing back. Now, why is it that everything can move then? If there's always equal and opposite forces, why is it things move? It's because you just look at the force on the object. Okay? I throw this ball, I apply a force to the ball is going to apply a force to me, but one, my mass is going to be a whole lot more, so there wouldn't be much acceleration. Well, there's a lot of acceleration on the ball. But two, I have other forces acting on me. I push this ball, okay? When I push that ball, my shoes are adding friction, fighting me back, so I can't go anywhere. The ball has no other force on it, which is why the ball goes. So I just want you to understand with Newton's third law, it just means look at the surface. On the hand to the ball, on that surface is where there will be always an equal force going back and forth. Always. Okay? Okay.
I even went back to it and pushed F5 even. Oh.
Okay. You don't need to copy that down. Whenever a force is applied, an equal and opposite force fights back. Okay? Alright. I don't want you to look at applied force. Don't worry about that. I want you to look at force of gravity, F sub g. And I'll let you copy that down. Whoa. Ready?
It's ready.
Wait, don't start yet. Ready?
Ready. It's already. Yeah. That's.
And we're back. Is that good? See? Yeah? That's called production value.
Yeah.
Okay, ladies and gentlemen. So, weight is a new term. You've never heard it before. Weight. It's a good question. Weight is actually different than what you know. When we talk about weight, we're not talking about pounds. We're going to talk about weight is a force. It's a force of gravity. Your weight is the force that gravity will pull you down with. Okay? And that will always be your mass, whatever your kilos are, whatever your kilograms are, times G. What's G always equal to? 10. And that's all you got to do. All right, now, with weight, weight is a force. Make sure you understand that. I swear, it's like maybe this would be a question on a test.
What is weight? Of course.
If force, acceleration, and gravity.
And it's always funny when I write this on a test, I say weight is a blank, and then you get just the silliest answers. Except their grades on the line. It's just not as silly. Weight is a force, ladies and gentlemen.
There we go.
Okay. Weight is a force. So again, weight is equal to mass times gravity. Always, always, always. Weight, we use F sub G, is weight, mass times gravity. Okay? And in fact, I'll give you the formula better. There. Nope, because there it is again. Now, it's a triangle, so just in case you need to solve for, say, mass. Weight is F sub G. If you need weight, if I say what is the weight, you put your hand over weight. And that means you were given mass, gravity is always 10, you multiply. What if I ask for the mass of a such and such Newton object? Well, if I'm asking for the mass, and I'm giving you newtons, that's the weight. That means cover up the mass, and then you get the weight. All right, I'm sorry, cover up the mass, and you get the mass. Weight divided by gravity will give you your mass. Okay? Okay. Here's that formula again for F equals ma. But again, same thing. Cover up what you need. If I need acceleration, I put my hand over acceleration. Force divided by mass is acceleration. If I need force, put my hand over force. Force equals mass times acceleration. Okay? Stop talking, turn around. Alright. Now, friction. I want you to understand friction. We'll pause there for you to copy it down. Whoa. Recording?
Yeah.
Whoa, okay, yeah. Alright, so, friction, I tilted it, didn't I?
Yeah.
Alright, friction is a force that will always go in the opposite direction of where you want it to go. Okay? Friction, if I push the stool along, this stool, okay, when I push the stool, friction is going to be going in the opposite direction. Always. Even if I want to just push it and I don't get it going. If I'm trying to get it going, friction is going in the opposite direction. So it always goes in the opposite direction of our intended motion. Alright, now there's actually two types of friction too that you want to know about. But first, there's a coefficient of friction. If you want to know how much friction an object has, you want to know about its coefficient. It's kind of the stickiness of friction. The more coefficient of friction, the higher coefficient of friction, the more friction it will have. So, and it's really talking about friction between two objects. So, the coefficient of friction of wood on glass might be different than the coefficient of friction of wood on concrete. Okay? So it's talking about how two objects interact with each other. Now there was when I was in high school, there was one of my friends did a presentation on rock climbing. And so he brought in these really expensive $200 rock climbing shoes. Okay, and they were like supposed to have the highest coefficient of friction between the sole's rubber and the rock that you'd climb. And so he did this big demonstration where he had this big flat rock connected to like a car jack, and he stood on it and he raised the rock up higher and higher and higher. And as he stood on it, he got up to this really, really high angle, and then finally he slid down the rock. And it was because he had such a high coefficient of friction, or his shoes had such a high coefficient of friction with rock, that they were very expensive because they were great for climbing rocks. Okay, rock, you know, or rock climbing and all that good stuff. So, the funny part was this: our teacher had these old, beat up Adidas Gazelles. Okay, and Adidas Gazelles were these old shoes that had like white rubber soles to them, like really, really worn down, and they only cost like $40 or something like that. And he had them. He must have them for 6 years. There was no tread to them or anything. So they said, all right, well, see how that's why these are $200 shoes. And they told the teacher, all right, why don't you get up on this rock and let's jack it up and see how high you go. And you're obviously going to go down at a lower angle. So he gets on the rock, they jack up the rock, and it goes higher and higher and higher and higher, and goes past the angle of the $200 rock climbing shoes. These old beat up Adidas Gazelles with no sole, which actually helped it, with no tread on them, were better for climbing rocks than the really expensive ones. Okay, so...
Was he embarrassed?
Huh? He was a little embarrassed because he said how expensive the shoes were, and they were, you know, didn't do it. So anyways, so yeah, you know, shoes obviously tread are good for going through different terrain, but you have, just in general, we're talking about shoes have different coefficients of friction, the way they interact with other objects. Okay. Now, there's two types of friction you want to know about: static and kinetic. Ever notice, like, if you have a big box you got to slide across the floor, or something really heavy that you have to slide across, it's going to take more force to get it going. It's always harder to get it going, but once it's going, it's easier to keep it moving. Ever notice that?
Yeah.
You have a really heavy object and you push, 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 and then all of a sudden it's going. It's a lot easier to push along. That's because there's two types of friction. Static, when it's staying still, and kinetic, when it's moving. Okay? Static friction will always be greater than kinetic. So it's always going to take more force to get something moving, but once it's moving, it'll be a lot easier to keep going. So you want to know about those, static and kinetic. Now, the reason you have anti-lock brakes on your car is because of this idea that static is greater than kinetic. If your wheel is turning on the road, okay? Here's my wheel. It's turning. Compared to the road, the wheel doesn't move. Okay? It just rolls. But on this point right here, as it gets to the ground, it doesn't move. Okay? Now if you skid, that's kinetic friction. So when a wheel is still turning, that's static friction. It's not moving relative to the ground. Okay? So static is stronger than kinetic. So when your tires get into a skid, if you lock up your tires, you're now all of a sudden in a skid. That's when there's going to be less friction. That's why there's anti-lock brakes, for that kind of idea. If your wheels keep turning, you have more friction. Once your wheels lock up and the car has to keep moving, it's going to be in a skid. And now it's going to be skidding and moving relative to the floor or to the ground. Okay? Okay. All right, here's the last equation you need to have.
Damn, that's the hardest one.
Force of friction is mu times mu, which is the coefficient of friction,
Yeah.
times mass times gravity.
That's the hardest one.